Good day, grade 12 learners. Welcome to today's Life Sciences lesson. My name is Samantha Ragunanan. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Remember, learners, you are able to WhatsApp us on 079 454 9535. I'll repeat it, 079 454 9535. Please send messages only and not voice notes or videos. Thank you so much. Let's get started. So today in our weekly life science lesson, we're going to cover evolution in present times. Evidence of common ancestors for living hominids. The presenters today, myself and my colleague Agnes Moabello. So let's get started. So firstly, we always kick off with the exam guideline. I'm sure you realize this by now. Not because we feel like it, grade 12s, because this is a very important document. So whenever you start studying, you have to start studying with this because we know that it is the recipe. Okay? So let's talk about what we actually need to know. Evolution in present times. We need to know any one example of natural selection. Just see. And evolution in present times. So this could be any one of the following: the use of insecticides and consequent resistance to insecticides in insects, the development of resistant strains of tuberculosis causing bacteria to antibiotics due to mutations in bacteria and failure to complete antibiotic courses, HIV resistance to antiretroviral medication, and the bill and body size of Galapagos finches. Sorry, that's a bit of a tongue twister, but you remember this from the previous lesson. So the finches we are not going to do today, but we have done it in the previous lesson. So you need to revisit that when you are studying evolution in present time. So when we talk about evolution, we know from our previous lessons, we know that evolution is a change in an organism over a period of time, which is usually a long period of time, in response to the environment around us. Okay, so today we're going to look at a different aspect of this. We're going to discuss evolution not way back then, evolution that is actually taking place today as we speak. So we can remember that life science is a subject that is ever changing. It's constant. It's today. Now, if we look at what is happening in present time, now I'm sure when you look at the diagram, you can already see, you recognize this mask from 2020 when everyone was wearing all these masks. And yes, that is the coronavirus. So you probably wonder, how is it that evolution is taking place in present time? It's because in present time, we also have organisms that are rapidly reproducing. As they are rapidly reproducing, they are constantly changing their form. So sometimes when you administer an antibiotic or a tonic to help to relieve ourselves of this virus or this bacteria, we can't get rid of it. So that is why when we talk about the COVID virus, there were many different strains of the COVID virus. There was the Delta, the Omicron, and the reason that they couldn't find a cure for it was because it is constantly mutating. That's the word we use in life sciences. Mutating, we know, is when it changes its form in such a way that we are unable to keep track of it, and it reproduces rapidly. The other instance of evolution in present time is the HIV virus. So now when we talk about the HIV virus, many of us know people who actually have the HIV virus. And this is useful information because the HIV virus, the people who have HIV, they need to take drugs. They need to take antiretroviral drugs in order for their immune system to be strengthened. But what happens when they don't take it consistently and constantly? The virus starts to mutate and multiply, and then the ARVs are unable to be effective. This mutation can also occur when there's an inability of the blood to absorb these antiretroviral drugs and so forth. Then we look at our next example, which is the Anopheles mosquito. Now, the Anopheles mosquito is the malaria-causing mosquito. So we know that if we, in our homes, if there's a mosquito, if there's anything around, we'll spray Doom, or we'll spray something called an insecticide for the mosquitoes or to get rid of the flies. So what happens is that certain organisms, they become resistant. They become resistant to the insecticides. And when they become resistant, we are unable to kill them or get rid of them with our insecticides. And this is what happened with the Anopheles mosquito. So what they were doing is they were using this insecticide called DDT. Now you might have heard of DDT. It was used many years ago. It was very popular because it was one of the cheapest insecticides you could find. So naturally farmers would flock and they would use this DDT to administer onto the Anopheles mosquito to get rid of these mosquitoes. But what had happened is, besides the DDT killing some of these mosquitoes, it was harming other organisms. So eventually, it was not allowed to be used. But what happened with the Anopheles mosquito is that the more they were spraying it with this DDT, some organisms were susceptible, and yes, it killed those mosquitoes. But others became resistant. So no matter how much you would spray those, they would just survive. And what happens when they survive? They reproduce. And when they reproduce the same type of resistant Anopheles mosquito. So what is happening? The population of a resistant Anopheles mosquito is growing very quickly. And then when we talk about bacteria and viruses, now in grade 11 we studied bacteria, and we know that when bacteria reproduces, it reproduces asexually. And we know we have good bacteria and we have bad bacteria. We've got good bacteria because we know when we go to the doctors, they give us probiotics and it helps our system. But then there's also bad bacteria, and this is disease-causing bacteria. So what happens with the disease-causing bacteria is that when they multiply, from your grade 11 work, you would know that when they multiply asexually, meaning they basically make clones of themselves. They make identical copies of themselves. They don't need a partner to reproduce. So because they don't need a partner to reproduce, they're able to do it on an accelerated level. That means bacteria can multiply very quickly. So this can be a bad thing, because when we discuss resistant bacteria, because now you can see we're discussing evolution during present time, and more specifically we're discussing natural selection. From our previous lesson, natural selection is when an organism has advantageous characteristics which enable it to survive in the environment, and when they reproduce and they multiply, that species has an advantage and is able to survive compared to other organisms. Okay, so let's talk about natural selection in, for example, the bacteria. So there we have the yellow dots, which is the susceptible bacteria. When I say susceptible, that means if we provide the person who has this bacteria in their body, if we give them antibiotics, okay, we give them the antibiotics, the susceptible bacteria, the yellow structures that we have here, they would be killed or they would be destroyed by the antibiotic, okay? But then if you look at these two red dots here, these are the resistant bacteria. And through natural selection, they're able to resist the antibiotics. And what happens when they resist the antibiotics? When they resist the antibiotics, they survive. And if you look at this second diagram here, you would see there's a lot more red structures than there are the susceptible bacteria, which means that what has happened is that they survived and they multiplied, and now the population is consisting of mainly resistant bacteria, as you can see there, mainly resistant bacteria. So this is what happens in the case of where we have resistant bacteria. So this is how evolution happens in our present times. The same with tuberculosis. Tuberculosis, there are certain strains of tuberculosis where even if we give the person antibiotics, the antibiotics are not effective simply because the tuberculosis has mutated. And because it's mutated, the antibiotics are not working. Another scenario with tuberculosis is when a person has TB, they need to take their medication every single time that it is diagnosed by the doctor. And if they miss their course or of their medication, what happens there? The resistant bacteria start to multiply, the resistant tuberculosis start to multiply, and then when they take the antibiotics again, it doesn't work. Okay, so this is evolution during present time. If we move on, now we're going to talk about certain examples, because now we know what evolution is in our present time. It's mainly through natural selection and mutation. So what we're going to do is we're going to do a past year paper, and we're going to try and unpack the knowledge that we have just learned. So with regard to the question here, I'm going to read it. The diagram below represents the changes in the population of bacteria as a result of exposure to an antibiotic over time. So it's changes in the population of the bacteria as a result of exposure to an antibiotic over time. Now notice I circled the key words. That is what we should be doing in our exam. We should circle or underline or take note of the important information. Now let us look at this diagram. If we look at this diagram, they give us a key. Before we look at the questions, we are going to try and interpret the diagram based on the knowledge that we know. Now here we have a clear circle here at the bottom, and that is where there is low resistance. That means, what does that mean? It means that that organism, bacteria is susceptible to antibiotics. When it's susceptible, that means the antibiotics can get rid of this bacteria. Then we got a striped structure, and that is a more resistant bacteria. And then we got a dark circle here, which means that it is highly resistant to the antibiotics. So what does this mean? If I look at high resistance, I know already, before I even go to the diagram, that the antibiotics are not going to, most likely not going to be able to rid the body of this bacteria. So let's look at the diagram. Now this is a question, grade 12, that you can score a lot of marks in, because it's got to do with a lot of diagrams. And diagrams, and a lot of this, we don't even need to study a lot for it. We just need to know that we have resistant structures and we have susceptible structures. Like, let's look at diagram A. Here we have the susceptible bacteria. So that means our antibiotic is going to kill it. Okay, and then here we have a more resistant. There we have more resistant, and then we got highly resistant. So what happens? We put the antibiotic. This is when it doesn't have the antibiotic. This is when after we've administered the antibiotic. And what can you see? It's basically counting here. If you look at the dark black dots, you can see in the first diagram there's 3. In the second diagram there's 1, 2, 3, 4, 5, 6, 7, 8. Obviously, the resistant bacteria has multiplied, which means, has the antibiotic worked? No, it hasn't worked, because obviously they're still there. And can we see any of the susceptible bacteria? No, there's no clear circles here on this side. Can we see the more resistant bacteria? There we go, 1, 2, 3, 4. We started off with 3, which means what can we conclude? We can conclude that the antibiotic has worked on the susceptible bacteria. However, with the more resistant bacteria, it worked to a certain degree. With the highly resistant bacteria, it has worked very minimally, because they've multiplied. And now look at the result. There is more resistant bacteria than there actually is susceptible bacteria. So what's going to happen if I'm going to give this person antibiotics? Are they going to work? If you really look at that picture, no, it's not going to work, obviously, because we got highly resistant bacteria here. So it's important that we understand this basic diagram, because you're going to get different versions of this diagram. So let's see what questions they ask us. Because if we look at the overview of this is everything that we learned in natural selection. Let's go to the questions. Explain in terms of natural selection. There we go. You see? The change in the proportion of the antibiotic resistant bacteria. When we talk proportion, we're talking numbers. Okay? of the antibiotic-resistant bacteria in the population in diagram B. So there's diagram B. So they want you to talk about diagram B, and that is 6 marks. So this is natural selection, as we said. We know that we need to mention, when it comes to natural selection, we need to let the examiner know that there was variety. We need to talk about the characteristics. So if there are 2 characteristics we're talking about, susceptible bacteria and resistant bacteria. So we can't only talk about one. We must talk about susceptible bacteria and explain what happens to susceptible bacteria. And then we must talk about resistant bacteria and what happens to them. And then after, at the end, what is the conclusion? What happens at the end of the picture? Okay? So with that at the back of your mind, let's look at the answer. So due to mutation, some bacteria are resistant due to mutation. Do you see that? Due to mutation, some bacteria are resistant to the antibiotic and others are not. Now I want you to take note of the mark allocation in grade 12s. There are 3 marks already here. Out of the 6 marks, there are 3 marks. Okay? So because we need to say why did this happen, and then we need to say some bacteria are resistant to the antibiotic and others are not. We can't just say some bacteria are resistant and expect the examiner to know that others are not. We need to explain everything as if the examiner knows nothing about life sciences. Okay? So the next mark, there is a large degree of variation in the bacterial population. So there's variation. How do we know there's variation? Because we got susceptible bacteria, we've got more resistant bacteria, we got highly resistant bacteria. So what does that mean? It means that there is a variety. There's not just one type of bacteria. So we need to tell the examiner that, because that's what we noticed. Okay? And then the next point, when the antibiotic was first used, the non-resistant bacteria died. The non-resistant bacteria died. Can you see? Because here, there is nothing here of the resistant bacteria. The resistant bacteria survived. There, the black dots are there. They survived. So yes, we can see it in the picture, but we must talk. We must not talk, actually. We must write. Okay? We must write every single thing that happens in the diagram. Not just one word answers. Explain the point. The resistant bacteria survived. And they didn't just survive. Because if you look at 3 and we look at the numbers on the number of resistant bacteria in diagram A and in diagram B, they're completely different. In diagram A, there is less resistant bacteria. In diagram B, there's a whole lot of resistant bacteria. So we already know that they multiplied. So therefore, that translates to they reproduced. That is why we can see so many. And we know that bacteria will reproduce asexually. So it will take place very, very quickly. Increasing the population of antibiotic-resistant bacteria. And I'm sure you say, yeah, but it's obvious. It's not obvious. You have to state that the population of resistant bacteria has increased. Okay? So I want you to look at this answer. And you must remember that you're not always going to be given bacteria. You're going to be given different scenarios, but you must be able to apply by naming the factors, saying that it's natural selection, saying that there is a variety of organisms because there is a variety of bacteria here, talking about the characteristics, talking about the fact that they reproduce and their numbers have increased through reproduction. So it's not just when you see 6 marks, you must write a few words. You need to explain yourself. Very often, grade 12 learners know they know what's going on in the diagram, but because you don't explain yourself sufficiently, you lose out on marks that you could otherwise have gained. Okay? So, the next part. Explain why antibiotic resistance, there again I'm underlining important words, can become severe health problems in hospitals. Okay? So, I'm sure you've noticed this. When we talk about antibiotic resistance, I'm sure you have someone in your family. They're always going to the doctor. They always got the flu. And even when they take antibiotics, then later on again, it will come again. Why? Because they've developed antibiotic resistance. So let us see what actually happens in hospitals. Because if I'm going to have antibiotic resistance, that means when I go to the doctor and he gives me antibiotics, and if my body is resistant to that, I'm going to keep going to the doctor, and what happens there? I need money for that. It's going to cost me a lot. So a lot of these questions are common sense. Let us see what is the prescribed answer. Overuse and frequent use of antibiotics may lead to the development of antibiotic-resistant strains of bacteria. Infections caused by these bacteria are no longer affected by the antibiotic treatment. Okay? And antibiotic resistance leads to higher medical costs, prolonged hospital stays, and increased mortality. That means if the person is going to constantly be resistant to this bacteria to the antibiotic, they're going to get more sick and more sick and more sick. And mortality, we don't like that word because it means death. Okay? It's not a very nice word. Humans, we don't want that. So that is what they are actually talking about. Okay? If we move on. Now, do you see how we've got different forms of the same question? So in this question, it's also based on evolution during present times. But as you can see, it's in a graph. So expect different types of questions. Go through past your papers and you'll be okay. You're gonna see, even if you're gonna do this question, we're gonna apply the same principles. So you already know how to do this question if you've been listening to me. Let's read. So this was in the 2021 paper. Some farmers add low doses of antibiotic feeds to their cattle. The use of antibiotic in cattle feed could result in the evolution of antibiotic-resistant bacteria. So what are they doing? They're putting antibiotics in the cattle's food. The graph below shows the effect of the different doses of antibiotics on the number of harmful bacteria in the cattle. So now we're not dealing with the good bacteria, we're dealing with the bad bacteria, the bacteria that's going to make them sick. Okay? So firstly, what we need to do is, before we even go to our questions, we're going to try and interpret the graph. Already we can see, if you look at the title of the graph, the effect of different doses of antibiotics on the number of harmful bacteria in the livestock. That's basically the question. Okay? And then we got the number of harmful bacteria, So it's 200, 400, 600, 800, and goes on. So what's happening? So the lower we go, the less the harmful bacteria. The higher we go, the more the harmful bacteria. We don't want to go there because that's danger zone. Okay? And then if we look at the antibiotic dose, so this is the amount of milligrams that they give to the cattle in the cattle's food. So if you already look, if we give the cattle 2 milligrams, okay, the number of harmful bacteria will be 1,000. So there'll be 1,000 harmful bacteria. That doesn't look good, because if the cattle are going to have an average of 1,000 harmful bacteria, they're going to get sick. Let's look when we administer. We're just going to extremes before we go to the questions. Let's look at when 10 milligrams of the antibiotics are given. And you're going to use a ruler, but if we have to go there, we can see that only 200 of the harmful bacteria are going to be there. So already we can see, guys, you don't need to know content here. You just need to know how to read a graph. This is a section you can get marks in. You just have to know how to read a graph. So let's see. So if I give 10 milligrams and 200 harmful bacteria are killed, and if I give 2 milligrams and 1,000, there's going to be 1,000 harmful bacteria left. And if I give 10 milligrams and there's only going to be 200 number of harmful bacteria, obviously I can conclude the more of the antibiotics that I give, the less will be the number of harmful bacteria. It's obvious. We just need to read the graph. We don't need to become overwhelmed every time we see numbers in a graph. Okay? So let's see the questions. Let's see if we know more or less now what we're going to do. Use the evidence. Now, Grade 12s, it's important that we pay attention to the question. We must give the question what the question is asking. If the question is asking for apples, we can't give bananas. Okay? We must give what the question is asking. So let's see. Use the evidence from the graph. So whatever answer I'm going to give, it must come from the graph. It must come from here. Okay? To explain why higher doses of antibiotics will benefit the farmer economically. Now, in life sciences, we do get this word quite often. Economically, we know it's money. Okay? So the farmers are not in the business just to be on the farm. Maybe some are, the rich ones, but most of them want to make money. So if they're going to lose cattle or livestock, they're going to lose money because they're selling these things, okay? These organisms, they're selling them. So let's see. What do you think is going to happen here? They ask, use the evidence from the graph to explain why higher doses of antibiotics will benefit the farmer. We can see, because of what I said in the previous discussion, okay? Let's see here. It decreases the number of harmful bacteria the most. So when we give more of the antibiotic, it will decrease the number the most. It's exactly what we were discussing. See how easy this is. Thereby preventing disease in the cattle, resulting in less medical expenses. Because you must know, farmers also have to, like how we have to go to the doctor when we're sick, they also have to pay medical costs to the vet when they take these livestock to the vet. Okay, decreasing mortality. If they die, okay, if the livestock dies, he's not going to get any money for them. Maintaining the number of cattle. That means if they don't die, the number will be maintained to sell and to breed and to increase profit, because it's all about the money, hey? Right. So do you see how we can get a question like this? Now, you won't only get it like that. You see this whole lot of words that you see in front of you. This is an example of an extract with an investigative question. Grade 12, it is a rule. When people are setting your paper, they tell them, you must set an investigative question. There must be, in everyday terms, there must be an experiment there. So here already, when I see an experiment, when I see an investigative question, I know they're going to either ask me something about dependent, independent variable. I know there's going to be something about an aim. There must be going to be something about a conclusion, because those are the components of a scientific investigation. Before you even go and attempt this question, you must know what the meanings of those words are. You must know how to get those, to get to those answers, given the scenario. So let us read. An insecticide is used by farmers to control insect populations of Phylodia interpunctella, which feeds on stored grain. Farmers treat the grain with insecticide to prevent an insect manifestation. The insecticide is extremely poisonous to certain insects, almost like the DDT, hey? Yet it causes little or no harm to humans and beneficial insects. So it's a little different. In recent years, it has been noticed that this insecticide is no longer effective in controlling insect populations of Phylodia interpunctella. Scientists hypothesized that insect populations that had previously been exposed to the insecticide had a higher survival rate when the grain was treated again. In an investigation to test this hypothesis, I want you to take note of that word while we are continuing. Identified storage bins that had previously been treated with the insecticide and bins that have never been treated with the insecticide. Collected a sample of 300 insects, kept in each sample in a separate container of equal size and the same conditions. Sprayed the same concentration. I'm seeing a lot of same here. Okay, so we must take note of this even when we're reading. And the volume of insecticide over both containers. Allowed 24 hours for the insecticide to take effect. And then they counted the number of insects that survived in each container. So going forward, before we look at the question, I told you what you need to know when you are going into an investigative question. But we've come across a term here called a hypothesis. A hypothesis is not a question. It is a statement which the person who is conducting the experiment, they're conducting the experiment to prove whether the statement is true or false. They are gathering evidence to discuss or to prove that the statement, whether it's a valid statement or it's an incorrect statement. Okay? So let us go to the questions that are posed on this scientific investigation. The results are shown in the table below. Most of the time, when you get an investigative question, there's going to be a table. And let's see what the questions are. But if we look at this table, we see that there's previous exposure to the insecticide and number of the insects that survived. So you have one group with a previous exposure to the insecticide and one with no previous exposure to the insecticide. But then I've got different numbers here. I got 182 here with previous exposure to the insecticide, and I've got 66 here with no previous exposure to the insecticide. Already I can see there's things that are changing here with regard to the number of insects survived. Okay, so let's see what they're going to ask us. But we already know what are the possibilities. There we go. Independent variable, dependent variable. They like to ask this. So you must be able to identify what is a dependent variable and what is an independent variable. And I know, grade 12s, it can be confusing. How I like to remember it is, okay, let's take dependent variable. Okay, a dependent variable is one that is the one constant in the investigation that is always changing. It's almost like if I tell you, what are you going to wear tomorrow? And then you say, I don't know, it depends on the weather. So that is going to change. So when you go to tomorrow, when you are changing, you're going to look outside and you're going to say, okay, the weather is cold, so I'm going to wear a jacket. Or the weather is hot, so it depends. It depends. So try and remember it that way. You're going to change. It's going to change according to the experiment stipulations. And then obviously the independent variable is the opposite. The one that the independent variable would be one that the person conducting the experiment keeps constant. Most of the time, the trend is, not all the time, but the first column is usually the independent variable and the second column is usually the dependent variable, because most of the time in the second column the numbers are changing and there's change taking place. So that is a little hack that some life science learners like to use, but it's not always the case. Okay, so let us see which is the independent variable. What is not changing in this experiment? And it obviously will be the exposure to the insecticide, as we can see here, because both groups are being treated with the insecticide. So there is something that they are keeping constant, but there's something changing when we look at these numbers here, because the numbers are changing. So the dependent variable will be the number of insects that actually survived, or the survival rate of the insects. I hope you now understand what is the difference between a dependent variable and an independent variable. See, it wasn't so hard. Just think of my example. Don't write it in the exam, grade 12s. Just think of an example. So there's an easy way to remember everything. Okay? Let's see. Next question. State 3 factors that were kept constant in this investigation. So if something is kept constant, then they want it to be, they want the experiment to be credible. Okay? So what did they keep constant? Remember, I was saying they're writing same this, same that, same that. So those are the things that they kept constant. And if you remember correctly, it was the sample size where they used 300 insects. They didn't put 300 insects in one and 400 in one, because that would influence the investigation. The size of the containers are the same. The conditions were the same. The concentration of the insecticide was the same. So if they sprayed 70% concentration of insecticide in the one container, they can't spray 100% concentration of the insecticide in another container, because that's going to not keep it constant. Then it's not the same experiment that they're conducting on both. The volume of the insecticide and the time period, 24 hours. Okay, so those are the things that kept it constant. So when we say it kept constant, that means it makes this whole experiment valid. Okay, it must be valid. The next question is, give two reasons why the scientist's results may not be reliable. Now, this is another common exam question in scientific investigations. They'll ask you, sometimes they will ask you, what makes the experiment valid? And then we're going to talk about what keeps it constant. But then they're going to ask you, what makes it reliable? If something is reliable, so how would I know that my experiment is reliable? Most of you grade 12 learners, you like to write, the minute you see reliable, you write, repeat the investigation. And you would be right. Repeat the investigation or increase the sample size. Those are the common answers. But remember, they're not asking why is it reliable. They're asking it what makes it not to be reliable. So we're going to say the opposite. So we're going to look at the question and we're going to see, okay, did they repeat the experiment? According to my knowledge and what we read, they did not repeat the experiment. They only did it once. Okay. Let's look at the marking guideline. It says they only conducted the experiment once. Now, in order to ensure that this experiment is reliable, we know that it has to be repeated a number of times in case something went wrong in one of those. Okay, they used a small sample, only 300 insects. So they could have used a larger sample because the insect population is so vast. There's probably about over 1,000 different species, but they only chose 300 insects, and they only used 2 storage bins where they could have used more. And I want you to notice in the question, in the marking guideline, they say mark the first 2 only. So grade 12, you can go write 100 different reasons why it's not reliable. Your grade 12 marker is not going to look at the rest. They're only going to look at the first 2 answers. They're going to mark it. So if those first 2 answers are wrong, you can write all the other 98 answers. They're all right, but we can't look at it because you must only mark the first 2. So remember that when you're giving your answers, give your most correct, even if you're guessing, your most correct guess first, rather than write incorrect answers first. Okay? So I'm just telling you about the marking rules, because even if your teacher or there's an examiner marking your paper, even if they see the correct answer, they have to now, they can't. Okay, they're only going to mark the first 2 answers. State the conclusion for this investigation, the conclusion. So remember when I said you need to know the components of a scientific investigation. Now, most of the time, not all, most of the time, when they give you a scientific investigation, they'll give you an aim. And then your conclusion is going to be related to the aim of the investigation. But in this case, they didn't. They gave you the hypothesis. So your conclusion is going to be based on the hypothesis. So you see there's tricks to remembering this. Okay? So let us talk about the conclusion. We already know what the conclusion is going to be. Insects that were previously exposed to the insecticide had a higher survival rate. That's 2 marks. Or insects that were not previously exposed to the insecticide had a lower survival rate. So that would be very similar to your hypothesis. So you have to prove whether that statement was true or false. So do you understand how a scientific investigation works? We need to know the components. So while you are studying, even if you don't know the components of a scientific investigation, go to your Mind the Gap. In the Mind the Gap, there are tutorials on scientific investigation, and you will see that you need to know how to identify what is the conclusion, how to identify what is an independent variable, what is a dependent variable, how to draw a graph, how to draw a table. These are scientific skills because you need to know them. You're not that lucky that they're going to take the exact same investigation. Every investigation is different. So you need to learn the formula and you must apply the formula to the question. Okay? It's easy peasy. You just need to learn the skills. So let's talk about evidence of common ancestors for living hominids, including humans. Again, the exam guideline. So very quickly, what do you need to know? You need to know how to interpret a phylogenetic tree to show the place of the family Hominidae in the animal kingdom. You need to know the characteristics that we as humans share with African apes. We share them with African apes. The anatomical differences between African apes and humans with the aids of diagrams. This is going to be nice because we can learn easy with diagrams. This is a section that is mostly made up of diagrams, grade 12s. And diagrams are our strength because most of us are visual learners. So this section actually is 1/3 of your paper. If you can nail this section and you can learn these diagrams and learn these differences and focus on evolution like you should, you're good to go. So bipedalism, the brain size, the teeth, prognathism, the palate shape, cranial ridges, brow ridges, all have diagrams. So I think we're going to do well in this section because we're going to be able to remember it. So now we're going to talk about the adult human, male and female, Homo sapiens, as we are called. This is just basically where we fall in the animal kingdom. Now, when you were in grade 10, you did classification. And then we did the animal kingdom and we discussed mammals in grade 11 and all of these things. So these all culminate to the grade 12 syllabus. We belong as humans to the domain Eukarya. We fall under the kingdom Animalia, phylum Chordata, class Mammalia, which I'm sure you are aware of, order Primates. Our family is Hominidae, and the genus is Homo, and the species Homo sapiens. Genus and species, these terms you must know. So how would you know which is genus and species? We're going to discuss it now. So this is our place. So here we have our place in the animal kingdom. We start off with the Hominidae. There we go. And then it moves on to the Hominidae, which branches out into Homininae and Ponginae. Okay? And we know how to read mind maps. So this is simple for us. We know that we are all not together. It's being separated according to the characteristics that we have. So Homininae will lead to Homo, which is the human, and Hominini will lead to the pan, which is the chimpanzee. So, you know, people that are going around and saying, yeah, in evolution, we are teaching that we are the same as ape. Look at this diagram, grade 12s. We don't look the same. I'm sorry, but I don't look like a chimpanzee. I don't. Look at me. Look at you. So yes, we share an ancestral relationship, but we are not the same. Okay? So then we have Homininae branches to Gorillinae and gorilla, and what we commonly known as the gorilla. And then we have the Hominidae goes into Ponginae, and then Pongo, and then the orangutan, and then so on. So you can see that Hominidae is the superfamily, and this is the family, that is the subfamily. Then we have the tribe, and then we have the genus. The genus and the species is something that we're going to interact with. So as much as we want to run away from all these fancy words, we need to know. We need to know what is the genus and what is the species. But lucky for you grade 12s, most of the time, these come out in diagrams. So all we have to know how to do is actually identify which one is the genus and which one is the species. I'm going to teach you how to do that. So here, our family name is Hominidae. We as human beings, our family name is Hominidae, okay? How are scientific names written? Now, I'm sure when you looked at your textbooks, they are written in very curvy letters and all of those things. We call them italics. Those of you who are busy on your laptops, you know that font would be italic. But because we are writing in the classroom, we have to have specific ways in which we can identify. So if you look at the genus and the species. Now the genus, you must remember, always has a capital letter. So Homo would be the genus, and species has a small letter, Homo sapiens. So if they ask you for the genus, a trick that I use is I always try to look for the word with the capital letter. Then I know that's a genus. Because, I mean, who can remember all these things? But if we know the key as to how people write the genus, then we will know how to identify the genus. Next, Gorilla, gorilla. Self-explanatory. Gorilla will be the genus and gorilla will be the species. Then we have pan, troglodytes. Pan will be the genus and troglodytes will be the species. And they also shorten it. So because scientists, we can't write now the whole long name, you can abbreviate it, you're allowed to. So instead of Homo sapiens, you can write H sapiens. But remember, that H must be in capital letters. And you see there's a dot in between. And then, if we look at the plural is for genus is genera. Okay, so we're going to go through this very quickly, and the interpretation of phylogenetic trees. So phylogenetic trees is basically where you have the branch, the trunk of the tree. Where the trunk of the tree is where you would find the ancestors. So this is like a family tree, but we don't call it a family tree because it's different. So here we have the past, and here we have today. Okay, so as you can see, as you go up the tree, you have characteristics that are found in the Ardipithecus group, and then there's another branch, and these characteristics are found in the Australopithecus group. So what is different from these two branches? They have different characteristics. And then you get the Paranthropus group, which also have different characteristics. And if you look at the timeline here, they're all formed on a different timeline. You can see there, okay? And here we are the Homo group. There you are today. We are still here today. The last time I checked, I'm still here today, okay? So that is what a phylogenetic tree looks like. It's basically, it starts with the ancestor, and then you have the descendants as you go up the phylogenetic tree. Please, don't confuse this with a pedigree diagram. A pedigree diagram is between close family relationships. This is between species, okay? So we mustn't make that mistake because they always like to ask this question. This slide is on what I've just explained. We always need to look for who is the common ancestor, who is extinct. They like to ask these questions, okay? But we're going to show this in the phylogenetic tree. When you look at the phylogenetic tree on the right, you will see a lot of branches. So when I look at the phylogenetic tree, the first thing that I want to know is who's the ancestor and who's the descendants. That's how I start looking at a phylogenetic tree. And remember, when we did evolutionary evidence, we said with the organisms with the least amount of differences are more closely related. So the speciation is actually based on that. So there we have it. The first branching, that is your common ancestor. And then the common ancestor for all the organisms is in the phylogenetic tree. There's the ancestor. And what would these be? A, B, C, D, E, F, and G, H. These are the descendants. You are not an ancestor. You are a descendant, okay? Maybe later on down the line you might be, okay? A, B, and C have a common ancestor at number 2. There's the common ancestor. So you can see, every time it branches out or it diverges, they develop a different characteristic. Okay, that is why we have the branches, because speciation has occurred. It's safe to say that B and C are more closely related because they have a similar ancestry at number 3. Okay, at point number 3. And we know that if we look at this phylogenetic tree, we can see that A, B, and C are more closely related than D, E, F, G, and H. Because we can see that they are more closely related. Their speciation has occurred on a closer level and they share common ancestors here. Okay, let's move on. Now you won't only get a phylogenetic tree in that way. We get a phylogenetic tree in this way as well. So what we're going to do here is we have the common ancestor, which was, when we look at a phylogenetic tree, we need to first determine which was the present and which was the past. So here we have the present, which is at 0, and that is the past. You'll notice that the graph is going in a different sort of direction as compared to how we normally use a number line. And then I'm going to give you common questions that they could ask. in the exam. They'll ask you, when did the common ancestor originate? And then you're going to use your ruler and you're going to go down and you're going to say 5 million years ago. Then when you see a branching out, that means speciation has occurred. So which descendants were formed? We'll say Australopithecus africanus, and then we'll name all of these. So that is one of the questions that they could ask you. And then when you see all of a sudden a break in the graph, as we see the break in the graph, that species has then become extinct. So they are extinct, and they could ask you, when did the species become extinct? And then you're going to have to use your ruler and go down, and it's going to be 1.5. Okay, so it's going to be 1.5 million years ago. They could ask you, how long was a species alive? Then you're going to have to go to where they originated and minus. So if they ask you Robustus, how long was Robustus alive? Then you're going to have to go where they started evolving. So for example, it will be 3 million years ago minus 1.5 million years ago, and that will give you 1.5 million years ago. So no, we won't put million years ago, we'll put million years, because remember, they're asking you how long were they. They're not asking you how far back. Okay, so that is the common exam questions. And then they could also ask you which species is now present today, and that's when we come to the end where there is a 0, because that is present day. Then we know that Homo sapiens is still alive today and the chimpanzee is still alive today. Okay, so those are examples of how to answer a phylogenetic tree. If you go through this diagram, we're going to go very, very quickly, because now we know the skill. Name the 2 genera that were bipedal and did not use fire. So here's the ones that use fire, so we know that we can't include them. And they give you a key. They say Australopithecus species, Homo species, and Ardipithecus species. So we know already, because they're capital letters, we know their genus, isn't it? Right. So they want to know 2 genera that were bipedal but did not use fire. So we're talking about these structures. And we can't talk about Homo erectus, because Homo erectus also used fire. So it will be Australopithecus species, and it will be the Homo species. Not the Homo species, sorry, Ardipithecus species. Okay. And then when did A. afarensis evolve? We're going to look at where the start of the graph was. And we know that they evolved 4 million years ago. How long did it take the hominid species to start using fire after they were bipedal? It will be 4.5. So here they are bipedal. This is where bipedalism started. Okay. Sorry, my line is not straight. That is why you must use a ruler. But there's the 4.5, and we're going to minus before they started using fire. So it will be 4.5 minus the 1, and it's going to be 3.5 million years ago. So for now, we're going to take a bit of a break, and we'll be joined by my colleague Agnes. But quickly to recap, remember, scientific investigation you must know. You must learn the skills for a phylogenetic tree, and do not confuse a phylogenetic tree with a pedigree diagram. There is genetics between close family relationship. We'll take a break for a few minutes. Thank you.
afternoon, grade 12 learners, and welcome back to our second session where we'll be continuing with the topic human evolution. My name is Agnes, and I'm going to take you through the last session. So we're going to be looking at the differences and similarities between humans and the apes. Yes, you'll agree with me that there are those characteristics that we share that are common between humans and other primates, and there are those characteristics that are different between the two. So let's look at this picture. Look at the bottom pictures and the top pictures and just tell me what you see there. All right? So if you look at some of the facial characteristics, for an example, with other primates, they've got 2 eyes, they've got 2 ears, they've got the nose, the mouth, and we also have those characteristics. Okay? But then, if you look at some of the characteristics, for an example, modern human, we are covered with skin. But if we look at the bottom there, or the top, all of those primates, the chimpanzee, you can talk about the gorilla, they are covered with what? With hair. Okay? So there are those characteristics that are the same between humans and other primates, and there are those that are different. All right? Now, if you look at we have studied the mind gap. All right? Now, in your mind gap, we have got this structures where we show you similarities between Homo sapiens and other primates. You need to revise that for your exams, your prelims, your end of the year exams. So it's important to use that resource, Mind the Gap, because it's easier to understand. Now, we'll be looking at similarities between Homo sapiens and other primates, right? So, for an example, if we start with number 1, we've got large brain size compared to their body mass. So, Homo sapiens and other primates, the chimpanzee, you can talk about the gorilla, they've got large brain size or large skull compared to the body size, right? Let's look at number 2. Look at the eyes. The eyes are in front for both humans and other primates. And then eyes are in front, or you can say we have got binocular vision. Since the eyes are in front, you can easily see binocular, the 2 eyes can see. Or you can just say stereoscopic vision. Those are the similarities between the humans and other primates. Look at number 3. Is pointing here. We've got freely rotating arms. You can rotate your arms. All your arms can rotate because of what? You've got those joints there, right? And then look at number 4. Number 4, we've got long upper arms. Now, all primates, the humans and other primates, we've got what? Long upper arms, right? Next, number 5, we've got the elbow joints here. Now, with the elbow joints, the humans, you can check yourself, you can check your friend, just to prove to test. So even with other primates, we've got joints that allow for rotation of what? For rotation of the arms. Now, as I'm doing all these activities, exercises, you can also do that where you are seated now, right? Then we have got 5 fingers. Humans and other primates, we've got 5 fingers, all of us. And then also we've got this thumb that is opposable to other fingers. Now we say we've got opposable thumb. Now this thumb, as it's opposing other fingers, it will help to do activities such as holding, gripping, and also as you are writing with your pens, that opposable features help you to can write. So it won't be so easy to write without. Maybe if you lose one of your thumbs, it will be difficult to do activities like writing, like holding objects. So we call those opposable thumb, which work in opposite direction with other fingers. So all primates and humans, we share those. Right? Now we also have flat nails. Check your nails. Check your nails, girls and boys. They are flat. Okay? Also, we've got bare fingertips. Observe also on your fingertips. Right? They are bare, and also they have what? They have got fingerprints. So when we check for fingerprinting, firstly, they will be checking what? The fingerprintings in your bare fingers, those fingers. Okay? Right? And then, if you can check also, there are mammary glands, and all humans and other primates, they've got 2 mammary glands. Remember, during breastfeeding, those mammary glands will produce what? Will secrete milk. Okay? Then, we talk about eyes with cones. Remember, you can now see color. You can see black, you can see white, all those colors. It's because of what? You've got cones at your retina, right? Eyes are with cones for color vision. I hope you understand that. And then all humans and other primates, we say they show sexual dimorphism. That's when you can see that, you can tell that this is a female, this is a male. Okay, so these are similarities that humans share with other primates, right? Let's move on. Now we are going to look at the differences between humans and African apes. Remember, my colleague Samantha mentioned that we're not the same. We're not the same with apes. But yes, with evolution, change taking place over time, I believe when we're looking at the phylogenetic tree, that's somewhere there we can see the branching of the ancestors. So we cannot say we look exactly like the apes. Now we're looking at the differences between humans and African apes. So if we look or we compare or we check for the differences, sometimes the examiner can say, give me the differences between humans and apes for 4 marks. For 5 marks, for an example. So it will mean you're going to give 2 differences there, and then 1 mark it will be for the table. So it is important that when you look for or when you give differences between the 2, make sure that you've got the correct table and not a cross. You must have a correct table that has got correct headings, because here you are differentiating between humans and the apes. So your headings need to be correct. You need to have a table that has got all the borders right in order to qualify for that 1 mark. Otherwise, we are going to lose that mark, which is just an easy mark. Those we call easy marks to get, right? Now, differences between humans and African apes. Humans, we say they are bipedalism, right? Now, you need to understand what is bipedalism. And we are saying African apes are quadrupedalism, right? So, when we say humans are bipedalism, it means they can move. Isn't it that you are moving, girls? From one point to the other, you're using your 2 legs, right? Hence, we are saying you are bipedal, right? In terms of the quadrupedalism, when we say African apes are quadruped, yes, they also move from one point to the other. They are using their 4. Quad means 4. So they're using their 4 legs for movement from one place to the other, right? Now we are comparing again, don't forget, is humans and African apes. So the foramen magnum is in a forward position, foramen magnum of humans, whereas in the apes, the foramen magnum is towards the back of the skull, But for the humans, the foramen magnum is in a forward position. So we really need to talk a scientific language here. Don't generalize. So you need to differentiate the two as guided by your exam guideline. Talk about the correct terms. So foramen magnum is in a forward position in humans, but in apes is towards the back of the skull. Again, humans, because they are bipedal, we're saying their spine is S-shaped, whereas with the African apes, their spine is C-shaped, okay? And then, in terms of the pelvic girdle for humans, is shorter, is wider. I will show you in the next pictures so that you've got more understanding what are we talking about. And then in African apes, the pelvic girdle is long and narrow. So I need to see those words when you're writing your exams, when you're responding in your answer sheet, right? So when you respond to all those questions, the pelvic girdle is shorter and wider. You can't be saying it's short and keep quiet. It's shorter and wider, whereas in the African apes is longer and narrower. So it's important to work for full marks, right? Let's continue. The other differences with humans, the cranium size is larger, whereas in the African apes, the cranium size is smaller. Now, when you talk about the cranium size, think of what? The bones that protects the brain. That is the cranium, right? Now, in terms of the size, in humans is larger, whereas in African apes it's smaller, okay? Let's talk about the palate shape, right? Now, remember, we've got the upper palate, we've got the lower palate, okay? So both humans and other primates do have that. But then in terms, or in the case of the humans, the palate shape is semicircular. A circle, a circle? But if it's semi, it's half of that. So palate shape is semicircular in humans, and then palate shape is rectangular in African apes, okay? We will be doing questions around this to check the application, whether you understood or you not, right? Now, let's talk about the dentition in humans. Remember, when all your teeth are, all the types of teeth that you have, you talk about the scissors, the canines, incisors, you talk about the molars, the premolars, all of them. They are 32 in an adult, right? As you are growing, and when you have all the correct dental formula, all your teeth are there, they are 32, right? Now, in terms of the dentition, look at yourself, you look at your friend, okay? Observe those teeth. So humans, we do not have the spaces, we do not have the gaps, unless if you have removed one of your, you have removed some of the teeth, right? So we don't have those gaps, those spaces. But in terms of their dentition for African apes, they do have gaps in between the teeth. And we call those teeth, those spaces, diastema, all right? And then let's talk about the face. Check your face, check your friend's face. We've got flat face, flat face. Then, with the flat face, scientifically we're saying we are non-prognathous. Talk about those words. They are not that big. You can, instead of saying flat face, say we are non-prognathous. But then, with the African apes, they have got the sloped face, meaning they are prognathous, right? Still on the differences between humans and apes, with humans, they've got cranial and brow ridge. The cranial and brow ridge, they're absent. We don't have the brow ridge. I'll show you what I'm talking about. Now, in terms of the African apes, the cranial and brow ridges are present. I'll show you what I'm talking about when I talk about those cranial and brow ridges. Okay? Now, if you are given a question that is looking for differences between the humans and African apes, it's important for you to talk about the skull, cranial, remember, compare the two. Like Samantha mentioned, if you talk about apple this side on the left side, you must also talk about the apple on the right side. You can't talk about the apple, then bananas all of a sudden. So compare all the characteristics in that order. So when we need those differences, yes, talk about the skull for humans and African apes, talk about the pelvic girdle for African apes and humans, talk about the dentition on humans and African apes. So that's the way of comparing so that you get all the marks. Now let us look at the differences between humans and African apes, looking at these pictures. Like I was showing you the table, differences in a table form, but now I want you to see what we're talking about. Okay, so we said one of the differences between a human and African apes is the positioning of their foramen magnum. Okay, now we said the position of the foramen magnum is more forward in human beings, right? Let's look at the skull number 4. Skull number 4. Now, when you talk about the foramen magnum, this is the foramen magnum. It is not a hole. Can I say it's a hole? No, it's a foramen magnum, right? So the position is in a more forward position. You need to say more forward position. So compare this 4 with this one. So this one is more backward, but this one is more forward. When I talk about this one, I'm referring to the foramen magnum. So with the modern human or with humans, it is more forward position. Why? Remember, you talk about the cause, you talk about the effect. So we have got the foramen magnum that is in a forward position. Why? So that the spinal cord is going to fit vertically here. Looking at the foramen magnum, the spinal cord is going to fit here, and it will determine your bipedalism. It will determine that you are going to be walking, moving on your 2 legs, right? And then in case of the African apes, the foramen magnum is more backward. Here is it, it's more backward. This one is more forward. Now with this position, because it is more backward, it simply tells that this is, or it simply tells that the African ape is a quadruped, meaning it has got 4 legs. It moves using the 4 legs, right? So what determines the movement is the position of the foramen magnum, which will allow the spinal cord to fit in. I hope that makes sense, girls and boys. Right. Now, look at this picture. Remember, we spoke about those characteristics to say we've got flat face, to say we've got large cranium, to say we've got this upper and lower jaws. Now, if this is the foramen magnum, it means this is the spinal cord that is going to fit vertical, and this will determine that you will be moving using what? Your 2 legs. Bi means 2. Bipedal movement using 2 legs. Okay. Now compare this one, this skull with this skull. So this is an African ape skull. So we've said in terms of the foramen magnum, it is positioned in the form of, it is more backward, right? If it is more backward, here is the spinal cord fitting into the foramen magnum. And this indicates that this organism, this animal, the African ape, is going to be having what? Moving using those 4 legs. Okay? Now, in terms of the shape of the spine, okay? Remember when we're tabulating, we've said humans have got S-shaped spine, and then African ape or other primates have got C-shaped spine. All right? So this is a spine, this is the spine, this is a human. Now it is S-shaped. It's like an S, letter S. So it's easy to remember. And then this is a gorilla. The shape of the spine is like C-shaped. So when you look at the differences between the shape of the spine, the gorilla will be having C-shaped spine, as you can see. And then when it is, or when we say the spine feeds vertically into this foramen magnum that is way backward, then it determines that this is a quadruped. Okay? It moves using the 4 legs. Then, in terms of the spine of human beings, that is proof of bipedalism. The spine is S-shaped. Humans have got S-shaped spine, therefore they are bipedal. Gorilla, it has got C-shaped spine, therefore they are quadruped. Use those words. Right? In terms of the pelvic girdle, this is the pelvic girdle, girls and boys, pelvic girdle, right? Now let's get the differences between the pelvic girdle between humans and other primates. So with the gorilla, check, it is long, and if we look at the diameter here, it is narrow. So it's good to identify those. To say the pelvic girdle of a gorilla or other primates is long and narrow, to get that 1 mark. Saying narrow only, you won't get the marks. It's long, then narrow. Then in humans, it's short. Compare the two. This one is short, but it's wider here. Then in terms of the humans or modern human, the pelvic girdle is short. It's short and wider. Right? Pelvic girdle, long, narrow in gorilla or other primates. In humans, is short and wide. So get those marks. It's easy to even get 150 out of 150, right? Then, if you look at the pelvic girdle, now with the pelvic girdle, this is a human, obviously, this is a gorilla. How do we identify the two? It is because this one is bipedal, movement is used by using the 2 legs, and then this one is quadruped because it is using the 4 legs for movement. Also, the differences there, you can see the spine, which is H-shaped, and it fits vertically into the foramen magnum. But this one, because the foramen magnum is positioned in a more backward way, then the spine there fits here, determining the quadruped, for the organism to be quadruped. Okay, now we spoke about the differences between pelvic girdle to say this one is long and short, I mean long and narrow. This one is short and wider. All right. This is the other picture that you can easily compare. Short, wider, long, narrow. Can you see the difference? Yes, let's move on. Right. In terms of the brain, differences in terms of the brain size. Remember, when we were tabulating, we compared the brain size of the two. Now the cranium, remember, protects the brain. There is part of the skull where the brain is found. That is the cranium. So we are looking at the cranium size. How big is it? Okay. So bigger cranium indicates bigger brain. So modern human, we've got bigger cranium. And this means we've got bigger brain. Also with what? With intelligence. Now the palate shape, I've indicated that we have got the upper and the lower palates, right? Now in human is curved. As you can see, the shape is curved, but then in chimpanzee, it is rectangular. The shape is different, right? And if you can check also, you can see the diastema, the spaces between the teeth. That tells the difference between the two. So humans have more curved palate, but then chimpanzee is rectangular. Okay, now let's look at the three. This is a chimpanzee. You can see the diastema there. Diastema, don't forget, those are spaces in between the teeth. Then we've got gorilla. What else can you identify? When you look at the three, sometimes we'll say give visible reasons. So with these ones, you can also see the dentition there. All right. Now this is curved, a bit curved, Homo sapiens, and then this one is rectangular. We've got spaces, we've got large canines, but then even if we've got canines, they are smaller than those other primates. Dentition. Now with dentition again, check. This is a gorilla. This is a human or modern human or men. Men refers to both. Okay. Now there is gap between the teeth. It's called diastema. I've spoken to that. And then we've got canines. We've got premolars. We've got molars. You know. But if you compare the two between the gorilla and the man, they differ because of the shape, because of the spaces in between the teeth, which are found in gorilla and not in man. Also, we've got large canines, but then check yourself, though they are large, but they cannot be larger than these ones of the other primates. Now, cranial ridges. I also said I'll show you what I'm talking about. This is a cranial ridge here for gorilla. This is cranial ridge here for chimpanzee. But look at yourself. Do you have the cranial ridge? No, there's no cranial ridge. So humans do not have cranial ridges, but other primates, they do have. Now the brow ridges, we need to understand where are they, what are those? So this is a brow ridge of gorilla, but in terms of us, humans, do you have a brow ridge? No, it's just a flat face. Can you see the brow ridge here? Right? Then let's do one activity here. Remember, when you look at the activities, given the diagrams, given the pictures, given the scenarios, you first look at what is given, then you can determine, you can guess the questions, right? So this is diagram A, this is diagram B, and then we've got X here, it's indicating where is X, and then we've got diagram C, we've got diagram D. So based on what we have studied, you can already guess the questions, right? Provide label for X. Remember, this is X. And what is that, girls and boys? Right, it's foramen magnum. Remember, it differs. The difference is the positioning of the foramen magnum between the two, humans and other primates. So X is a foramen magnum. Right, let's look at the other question. Tabulate two anatomical differences. Anatomical, bodily structure, differences between jaws of diagram C and diagram D. Now, for 5 marks, Obviously, 1 mark is for the correct table. Now your table must have what? Your table must have correct headings. Remember, here you are comparing differences between C and D and represent trends in human evolution, right? You'll be looking at C and D, giving the differences. 1 mark is a free mark for table. Don't draw a cross. Let it be a full table with all the borders, right? Here is it. Diagram C, diagram D is given. So for you, it's just to collect that 1 mark. Then you only give differences with what you see there, right? Now, talk about the canines. You can see the canines. There are large canines here with the diagram B, because this is a human. There are no what? We don't have canines. If we have, they are small. Yes. Here is it, small, and then large canines. So large canines, small canines. Right, diagram C, what do you see there? We've got spaces. There's diastema. Spaces are present in between the teeth, whereas there's no spaces in between the teeth in humans. And then the last one, the jaw is U-shaped. It's like a U, but then this one, the jaw is C-shaped. Remember, we said it's semicircular, okay? We continue with this activity. Give a letter only of the diagram that represents, okay? A, the skull with a larger brain capacity. You having diagram A and B, don't forget, we're still on that diagram. Give the letter only. The skull with a larger brain capacity. Comparing the two, B has got larger brain capacity. This one, okay? Now, give a letter of the diagram that represents a prognathous skull, a prognathous skull. So with a prognathous skull, we've said it's A. Remember, we spoke about prognathous, and we've said humans are non-prognathous, flat face, remember? Account for the position of X in the skull in diagram B. Account for the position of X. Look at the question, it's 2 marks. If you are accounting for the position of X, firstly, you need to know what is that X. You need to name that X for you to get full marks. So you are accounting for position X in the skull of the diagram. Therefore, we're saying X, remember, we've said X is what? It's a foramen magnum. For what? It helps in doing what? So it's a foramen magnum where the spinal cord, the spine is going to fit vertically there. So this is X is a foramen magnum. Is located in a more forward position. We need all those points. Why in a more forward position? So that it helps the spinal cord to enter vertically, or it determines the organism to be bipedal. So you need all, mention everything. Then you're going to get full credit for all those answers, okay? Now, explain the significance of the shape of the spine, the importance. Explain the significance of the shape of the spine. You are going to talk about the shape of the spine that is associated with the skull in diagram B, okay? Now, the importance of the shape of the spine there. The shape, remember we've said, is S-shaped, and then why S-shaped is to balance the weight above the hips. Okay, now the spine is S-shaped. Why do we have the S-shaped spine? The spine helps us in the balancing. You are sitting down now, or you are standing up, you are being assisted by what? By the spine. So the spine is S-shaped to balance the weight above your hips, right? To support the weight of a bipedal organism, right? Lastly, we're looking at the picture below. We've got picture A and B, okay? This is picture A, this is picture B. The picture below shows the parts of the skeletal structures of the two hominids. 2.1. Name the term used to describe the locomotion of B. Where is B? Here is B. Name the type of locomotion. We spoke about that already, and the type there we say it is a quadrupedal, this one, B, because it is moving using the 4 legs. Now explain the position of the foramen magnum. Is even given for 6 marks. You are explaining position of the foramen magnum. The next thing, the shape of the spine, right? Then talk about what? The pelvis, structure of the pelvis, right? Let me read the question again. Explain how the position of the foramen magnum, the shape of the spine, and the structure of the pelvis are suited for the type of locomotion in A. So in the question, you already have got answers there. So it means, given this question, you need to address the position of the foramen magnum, the shape of the spine, and also the structure of the pelvis. I know you can already do that because we have looked at those characteristics and compared all of those. So what we are saying, the foramen magnum is in a more forward position. This is human, don't forget. This is man. Foramen magnum is in a forward position. Why? To allow the spinal cord to enter vertically. That is a point, right? Also, talk about the shape of the spine. The spine is more curved or it is S-shaped. So, it's so easy to pass life sciences, all right? So, it's important to know the structures, drawing and labeling, and also giving the functions. Then you can get it, right? So the spine is S-shaped. Why? To absorb shock and to allow for flexible movement. So if your spine is, the spine is in danger, or maybe the discs have shifted, it's going to be difficult for you to even move. Because if the spine is hurt, maybe in an accident, some people end up using what? The wheelchairs. So the spine is there to allow flexible movement in order to support. Also, in the question, they say, talk about the pelvis. Now, the pelvis is short and wide. Remember, in men, we've said it's short and wide, but in other primates, it is long and short. Remember that? So the pelvis is short and wide, is broad to support the upper body. Is long and wide so that it supports the upper body, right? Or it helps you to sit in an upright position. That is why even when you sit in your posture, we don't recommend that you just sit like you don't get any balance. Sit up straight, walk up straight, So you do that because of what? Because of the pelvis that is supporting the upper structure. Right, the last question, differences between humans and African apes. We've got diagram below that is showing the skulls. So with evolution, when evolution takes place, you can even tell and place in order the organisms, whether they evolved from this structure to that structure or to that structure. Now we've got structure A, B, C, right? Now you can tell A, looking at the flat face, also the cranium, comparing to B and C. Number 1, arrange the skulls A, B, C from oldest to youngest. Youngest will be the modern human. Oldest will be from million years ago. All right? So it will be BCA. B, C, this is the youngest. Right? Describe the significance of the difference in cranium size between skull A and skull C. Describe the significance of the difference in cranium size. Here, you talk about the size of the brain between the two. Right? So the cranium of skull A is larger. Cranium is larger. This one is smaller. Okay? So it's larger than C. Cranium of A is larger than C. This is how you need to phrase your answers. Then indicating an increase in brain capacity. So remember, this has got an increase and influence in what? In intelligence also. So brain capacity has got influence in what? In intelligence. Yes, you are more intelligent. You are more intelligent than other primates. If I were to put a man here and put a chimpanzee here, you are more intelligent than the other primates. Describe two visible reasons in the structure of the jaw of skull A and B. This is skull A, this is skull B. Describe two visible differences. So don't talk about any other difference that we have studied about. But here you write about visible, the ones that you see on this diagram. So describe two visible differences in the structure of the jaw of skull A and B. Skull A and B. Talk about the jaws. Write about the jaws. So skull A is not prognathous. Yes, we can see that. We've got flat face and then less protruding jaws than skull B, because this B is like a slope. But here we are seeing a flat face. Hence we are saying structure A, skull A is not prognathous. Less protruding jaws than skull B. It's a mark. Or you can say skull A has a well-defined chin. You can see a well-defined chin. But with these ones, because they've got that larger palates as well, you can't see the chin. The chin is not clearly visible there. So skull A has a well-defined chin, whereas skull B does not. Skull A has smaller jaw, whereas skull B has larger jaw. I've spoken to that. So all visible differences, you must talk about what you see and not any other difference. All right? So as we come into the end of the session, human evolution, I hope you are well equipped. You know, we've gave it all. Practice all those questions so that it's easy. You know, if you can look at all those questions going back to evolution by natural selection, you know, you're going to get those types of questions. Yes, we can give you a different scenario, but in terms of generic questions where you are describing natural selection, make sure that you follow the exam guideline the way it is. But then when we give you scenarios, apply the generics to what is given. I want you to wish you good luck and thank you so much. And make sure that you attend all these lessons. If you don't attend, make sure that you get recordings of that so that it helps you as you are doing self-study to prepare for the prelims. Thank you very much and goodbye.